Here's a Husqvarna 262 XP. Great saw. This one belongs to my neighbor, but it has a little problem. Unfortunately, that mounting ear is broken off, and it's a real bummer because the saw starts right up and runs strong otherwise. So I'm going to get into it and see if I can, looks like, get the case half that I need to replace that, or if that's not possible, see if there's some way that I can securely rig this and repair it to make this saw serviceable again. So here we go. Well, I was able to spin off the broken tab thanks to this inner screw that was fairly loose. This is what holds the spring to the body. Looks like the spring will need to be replaced as well. It looks like it's pretty bent up and damaged. But once I had that off, I was able to look up a little closer on the remaining portion of the case here and see that there's more cracks, and it's looking less and less likely that I could weld this tab back on or reattach somehow to some good metal up above it. So it's looking like I need to replace this side of the case. So next thing I'll do is just disassemble, get the tank off at least, start looking around to see if there's other major parts that would have to be replaced in addition to the case. In the end, I think I'll probably have this thing torn down to every little tiny piece, but the short term to get it apart, you can unsnap these clips, take the top off, and then reach in and just pry the fuel hose off the side of the carburetor, and that will let you pull it out the bottom of that top part of the case and allow you to separate the handle without further disassembly. Anything I can't screw right back together, I'll just lay it out on the bench like this in the same orientation as the saw, and I'll just snap a picture so I can come back and look at it later. I'll also snap pictures of missing or damaged parts as well as part numbers so that when I'm back at my desk, it's easier to know which parts to search for. Well, disassembly of this 262 XP is like just about any other Husqvarna I've taken apart, except that one thing that's different is the amount of buildup of oil and sawdust that's in here. You think this thing's been used? I'd say so. And there's a Husqvarna 262 XP all taken apart and sitting in a bin, cleaned up and drying out. I needed to take this all apart to see if any parts needed to be replaced. I found little things like rubber mounts and missing exhaust screw, and this is actually one of the more surprising ones. This is like a carburetor adapter, and it just cracked as soon as I went to go clean it. So probably just from heat cycling. It's like a plastic part, so I'll get another one of those and a few other small things, gasket kits, seals, and that case half itself. So not looking too bad so far. So I thought I would film some stuff fixing up chainsaws, but it's tough to do when you've got a Dexter the cat out here asserting that this is his space and I am in fact his human. Isn't that right, Dex? Yeah. He's a cutie. Oh, yeah. Oh, and I'm a climbing gym. Oh boy. If you're working on a 262 XP, then like me, you're probably considering a lot of used parts. And oftentimes you can get the part you need from a different model from the same family. However, there are variations you have to be aware of so that you know what is compatible with the saw you're working on. There was variations across different family members and also across different eras of manufacture. So I want to take you through the major ones that I know about using these two saws as examples. Now in this family, there was at least 4 saws, a 254, a 257, like I've got on the bench here, 262 XP, and also a 261. And by the way, all 262s are XPs, so I may say 262 just to shorten it up at times. But for specificity, let's go ahead and look at the serial numbers on these two. This one was built in the 51st month of 1994, so right at the end. And this 257, the 36th month of 1996. Starting from the top down, the 262 XP being the so-called professional saw, it has the 2-piece cover, and you only need a flat blade screwdriver to undo these clips. Take off this cover, you can inspect the air filter really easily. The 257, and I believe the other models as well, have this 1-piece cover. It requires you to remove some screws to access it. And they also have different air filter elements. So here's the one from the 257. I don't have the one from the 262 XP. Let's take off the second part of the air cover, and nothing else is really too important on this, the starter side of these saws. So let's spin them around and we'll get into some of the other differences. Many of the interesting differences are here on the PTO or clutch side of the saw. First one to look for is this hole right here. It's present on both of these examples, and the 257 has the rubber bushing that goes in there, and it's meant to accept this metal pin on the metal clutch cover. This clutch cover came with this 257, and it's the metal clutch cover. Meanwhile, this 262 XP came with a plastic clutch cover. No pin back here, but it does have a plastic tab which locates it in the rear. Now, because both of these cases have the hole there, either one of them could be loaded up with the rubber bushing and accommodate this metal clutch cover. They similarly could use the plastic clutch cover because all that requires is this little opening in the back where the tab inserts, and then you bolt it down. However, there are cases that don't have this hole, and in that case, they were designed to use the plastic clutch cover. That's the one you need to use unless you really want to use a metal one, in which case you could cut off that metal pin. Other important differences in the chain brake mechanism are that in the metal clutch cover, you have this sort of overlapping spring where the spring is kind of a half width and overlaps itself. In the plastic clutch cover, it's the full height all the way around and doesn't overlap. This rubber guard is specific to the plastic clutch cover. It will not cross over to the metal one. And so these are important things to be aware of if you're rebuilding your chain brake. Another difference is in the clutch type that's used. This 257 has the 2-shoe type clutch, whereas the 262 XP has this 3-shoe. Another detail to be aware of is this bolt hole right here, and this holds one of the bolts that holds the two cases together. It's located just underneath where the bar mounts, and the important detail is the depth of recess on that hole. Both of these cases have the deep recess style, so these are the new style cases, whereas older style cases have less recess and the bolt head sits more flush with the surface. That affects what set of bolts you use to clamp the cases together. This is the correct set of bolts for this case, so you have the long ones that go through the dogs and into these holes up front. You have a little shorty in the back, and in the middle you have 5 identical bolts, 1 for that recessed hole, and then 4 more that go around the crank. If you had the style without the recess, then one of these bolts would be extra long, and you'd have just 4 that are identical around the crank. Another difference is in the style of anti-vibration that's used, and this 262 with its broken tab here actually makes it pretty easy to see where one of the anti-vibration springs is located in the rear. This 262 actually has 3 springs, 2 in the rear, and a big one up here on the PTO or chain side with just 1 rubber bushing on the flywheel side. Contrast that with the 257, which has rubber bushings all around. 2 in the front and then 2 in the rear, which are much harder to see, but no springs on the 257. And that means that these 2 tanks are not interchangeable. Plus, this 262/261 style tank has this little compartment in the back for storing snacks. You may not realize that you're actually time traveling right now, and that's because I was just about to publish this video when this showed up in the mail. So I'm going back in time to where I was comparing different saws from the same family, now that I have this Husqvarna 261 to show you as well. This one was made in 1999. I believe they were only made in 98, 99, possibly in 2000. This case is identical to those that I showed you, with one important difference we'll get to. But in terms of the similarities, it has this hole here with the rubber grommet for accepting a metal clutch cover. It also has the deeply recessed hole here for the frontal case bolt, which is the same length as the 4 around the crank. Otherwise, these 261s were set up to mimic the 262, which had been discontinued at this point, and that means spring style anti-vibration. They have the same snubbers that were on the 262 as well. One difference from the 262 is that it actually would have had a 2-shoe clutch like this 257, and that's probably because this was actually a derated, detuned version of the 262. It had the same cylinder, but it had a dished piston for lower compression and a more restrictive muffler as well. So this is called an EPA saw. It met emissions, and it was only sold for a couple of years. The big difference is that it lacks the slot for a plastic clutch cover. And I think I know the reason why. I think that this family of saws started with the plastic clutch cover, but due to the way that the exhaust was exiting, there was some plastic melting going on. I can attest to that here. And so they switched over to a metal clutch cover. And by the time this 261 came along, they must have completed that changeover. And being in a 1999 saw, they just didn't even bother making the slot there. So this is a metal clutch cover only saw as it sits here. And that's the big difference that I found so far. In case you want to see, it actually has the exact same, not serial number, but part number, 5018600 as the 262 XP, 5018600. You can even go as far as shooting a light down into the oil tank. You can see another place where the part number is actually stamped inside the case. And that reads 5018601, and then it has a V3 at the end. So V3 would be like version 3, except the same thing is going on the 262. So I guess they really are the exact same part in that they're the same casting, but obviously on this 261, they just left out a machining step, and that's why it doesn't have the slot there. So I'm almost ready to tear this down the rest of the way and split the case, but before I do, I want to get a squish measurement, and to do that I'll use the flywheel just to help me turn the crank over by the spot where that key hits the crank. There we go. So to get squish, I've just got some thick solder here, and I'm going to give it a little bit of a bend so that I can insert it in this spark plug hole, and I want to reach all the way over here and find the amount of space between top dead center of the piston and the top of this cylinder. So I'm just going to kind of hold it towards the end and let the piston come up and squish it, and I'll turn the crank over by hand using the flywheel. That's what you get, a nice, clean, flat, squished area on the end of your solder. We've got some basic calipers here, nothing special, but they're zeroed out, and we'll measure it down there towards the end, not the very end, because that could be affected by the, their tolerance where the piston and the cylinder meet, and any little bit of room that's normally taken up by the ring. I'm getting into the weeds here, but measuring it just before the very end, and I'm getting 40 thousandths. I think that's a little high, but I'm not really quite sure. I'm gonna have to do some research on this engine and find out what people recommend for squish numbers. This may be a candidate for a base gasket delete, get a little higher compression. So I'll have to look into that. But now we have a baseline measurement, so we can go ahead and tear this down the rest of the way. So there's one of our seals. This is disassembled from the top, 4 millimeter. And we're removing the cylinder. There we go. Now we can look inside the cylinder for the first time. Really can't tell, to be honest, until I wipe it down, but here's our piston. Give it a little wipe off. Yeah, a little bit of gunk, but no heavy carbon buildup. The ring obviously nice and springy, sticking out. I'll pull off the piston. So I've just pushed through the wrist pin that holds the piston on. It's a tight precision fit. And our bearing, of course, is inside the rod on the crank here. The wrist pin bearing, wrist pin, of course that goes into the piston. And we have spring clips on either side that hold the whole assembly together. So I can clean these individually, set them off to the side for now. Now let's see if we can measure the thickness of this base gasket. It wants to come off pretty easily. Yeah, it's just barely stuck on there. That's good. Not too cooked or damaged. Actually in really good shape. We'll measure it from some place where I can access it without a raised edge. And this looks to be a 30 thousandths base gasket. We'll measure one more place, just for fun. Yeah, 30.5. 30 thousandths base gasket, 40 thousandths squish. So those are our baseline numbers for squish and compression. Now this is a case splitter. Ordered online, just arrived. And it's nothing more than a vise specially shaped to be able to reach over and grab the back of the bearing inside the crankcase and then press against it using this little, I don't know what you call it, pilot hole that is drilled into the center of the crank on both sides. That's what this little tip fits into. These two parts right here are basically the pads that are going to sit on the back side of the bearing. I believe I want to hold this crank straight up, slip this in, and just feed this until it engages into the crank. And then I'll hold this contraption up to show what's going on. But right now we're not trying to remove the bearing from the case, we're just trying to get the bearing to slide off of the crank and let the case open up at the same time. So at this point we should just be able to simply turn it by hand and have that case and bearing come off the end of that crank. There we go. That was an important sound, I think. It's definitely moving. You can see a gap all on there. Now it's getting much more easy to turn. There we go, we're through. So now let me back this out. Take off the case splitter, and voila. There we have it. Of course, this front part is the oil tank. This tube leads to this, which might be a vent. Yeah, I think that's it. And there's another part, which is the pressure side. So that's the crank removed from one side, and we'll set it on the flywheel side. Again, this is just removing the crank out of the picture, and in so doing it allowed splitting the case. We are not, at the moment, removing bearings from the case. Okay, here we go. Let's find a good position. That looks like a good position as any. And there you go. You hear it moving. Ooh, it is pressed on there tight. This one's actually significantly harder than the other side was. I might have to get a cheater bar or at least a better positioning. Yeah, actually what's happening here is you can see the fingers on the back side here are spreading a little bit, and we are off the side, the back of that bearing. So at this point we're pressing the bearing out. I don't want to do that. So when you loosen this up, I do not want to press this bearing out of the case. That needs to be done with heat to avoid, marring up the case. So I think I'm going to squish these together a little bit in my bench vise, which is off camera. I'll be right back. So now that I've squished it with my vise, these ears are closer to each other. I expect a little bit of trouble actually putting this on. It has to basically spread again a little bit to fit past the rod, and there we go. Okay, so now we're tightly pressed on either side of the crank, and that means we're touching the bearing as tightly as possible. And while that's there, I'm going to engage the pusher part on the other side. Let's hold it like this. That's more comfortable. Now I can press down too. Be sure that my case splitter is in the optimum location. Oh, not sure if that's a good thing or not, but something happened. It got easier afterwards, and the bearing hasn't been pressed out, so I'm going to assume that means that our crank came loose from that inner raceway of the bearing. Whew, that took some doing. So here's the bearing. It did actually move a little bit, and now I get my first feeling of these bearings. I'd say those are not great, because they're even lubed up right now and they're still making that. Yeah, this is the PTO side, and it's pretty loud too. Let's take a look at the crank. It definitely has a little bit of discoloration. Once I wipe it, there's really not much, nothing to trip my fingernail. And I'm gonna fully clean this in probably ultrasonic, but for now, there's the crank. This bearing feels pretty good on the bottom of the rod. It won't move this way. Okay, so I think our crank is good. The next step will be to remove those bearings, and I'll show you how I'm gonna do that next. I've got these cases all cleaned up, and now I want to focus on getting the crank bearings out of them. And the way that's done is by heating the entire case and the bearing. I'm going to be using this sort of industrial or lab style oven that I use for work, but you don't have to have one. You can use a heat gun, and I'll probably use that to apply extra heat right where I want it later on as well. You could even use an indoor kitchen style oven as long as you can regulate the temperature really carefully. I'm targeting about 250 degrees Fahrenheit, which is about 120 C. And the idea here is that you don't want to press out the bearing, because that could actually damage the bearing pocket and cause it to be loose when you put the new bearing in. What you want to do is heat up the whole thing, the case and the bearing, and due to the different materials, this being, I believe, aluminum, but possibly magnesium, it's going to expand at a faster rate than the steel of the bearings, and that's going to create looseness around the bearing and basically release that press fit, and the bearing should fall right out. So let's see if that's true. Let's go ahead and throw them in the oven. The only thing that I could be melting here is this oil straw, but I'm going to worry about that when it happens. I think it may actually survive that 250 degrees. So we'll put these in, let the temperature come back up, and let it sit there maybe 5-10 minutes. That will make sure that the entire case is thoroughly heated, and then I can take it out. If the bearings don't fall out, then I'll use the heat gun to apply some spot heat right around the bearing and just see if I can push them out without much force. That's the idea. Okay, it's been about 15 minutes with the oven closed at 250 degrees Fahrenheit. Let's pull out the flywheel side and see what we've got. I want to take a temperature measurement here. The case looks like 232 degrees. Let me turn on a spotter. Yeah, 232, so not as hot as the air inside the oven. Let's look at the steel as well. 223, 24. So both are about 225 degrees just for reference. And let's see if it will just push out. No, doesn't want to push. I've got a 1-inch socket here that I can use. That did it. So by having the 1-inch socket, I was able to put pressure all the way around and probably avoid binding it at all. Not too bad. So here's our bearing. It's a 6202, and looks like it's a C3 style. But in any case, bearing came out at 225 degrees measured at the material. Let's try for the PTO side now. So the PTO side I saved for second because it might be more complicated due to the style of seal. So the bearing actually can't go all the way through on this one. It's got a seal on the outside. Let's see if we can pull that out. One-handed might be more ambitious than is realistic. Let's give it a go anyways. It's definitely nice and warm. There we go, it's coming out. So I'm just using a little pick here with some prying pressure to pull that seal out. Obviously, I'm not worried about harming the seal. It's going to be replaced. Interesting. Let's come back to that, but that's what the seal looks like here on the PTO side, thus exposing the bearing. Oh shoot, my socket won't fit. Can I do it with my thumb? Ugh, I don't think so. This one's going to go back in the oven. I'm going to find a socket that'll fit in there so I can push more evenly. 5 more minutes in the oven, and I've got some additional tools to help me this time. So let's pull it out. First thing is basically a Tupperware container that I can use to set this up on top. Thus, I won't harm the hose that's sticking out that goes to the oil tank, but I'm losing my heat. So I'm just going to go ahead and get at it with the light hammer blow. Oh, doesn't want to come out. The 3/4 inch socket lets me access the inside there. It's off the rim a little bit. I'm not sure if I did anything to affect that or if that's how it was, but now we can go to stage 2. And I can heat it up locally with this heat gun. We will go ahead and see if we can push it out. Here's that 3/4 inch socket. Doesn't look like it. There it is. Now this is obviously a dead blow hammer, not a sledge, so I'm not hitting it that hard. For reference, the temperature that we got that center part up to, if I can get a read on it. Yeah, not much hotter than the previous case. Yeah, I'm not sure. I guess I must have lost some heat in the process of removing that seal, because even with the heat gun that you saw me applying extra heat with, we still only got up to about 225 Fahrenheit, and even cooler now. Can it really be cooling off that fast? Wow. Yeah, 216 degrees and falling. Amazing how quickly this cools. I guess from a material standpoint, it does kind of make sense. So you've got 250 degree ambient, and I'm using Fahrenheit here, ambient heat. That's going to theoretically get all this material up to the same temperature, but opening the door and other factors may change that a little bit. So let's say we got the temperature of the material up to about 225 Fahrenheit. Well, this being aluminum or magnesium, both those materials have great thermal conductivity. So effectively, this entire thing becomes a radiator as soon as it's taken out of the oven. And it's really actually difficult to affect localized heat. That's why TIG welding with aluminum is difficult, for example. The heat doesn't stay where you put it. It actually wants to even out across the whole part. So this entire thing was basically radiating heat away, and I'm kind of amazed, even with 1400 watts focused on it for a while there, temperature really only got up to about the same temperature where we saw the bearing release on this flywheel side of the case. So if anything, it's just consistent, it makes sense. The bearing again here is a 6202 C3. That's a totally standard, this is an SKF, but you can find it made by Timken and others as well. Obviously it's been washed and now heated, but you can really feel the grittiness of it. Even if I lubricated this one, it would still be loud, and definitely time to replace these. But that's both bearings out of the case, and you can see that that case pocket really finely machined, and you don't want to score that up or create any little peeled off shavings that could prevent the new bearing from seating all the way down. Again, I'll point out this side, the PTO side, has a stop on it that prevents the bearing from going any further, and that obviously will make it easy to set the bearing depth. On the flywheel side, we have just a regular through bored hole, and the seal is retained by an external means here, whereas the seal presses right into the that outermost part of the case on that side. Cool, bearing removal done. So that concludes the disassembly of this 262 XP into its smallest parts. And I've got a gasket and seal kit for building it back up. But of course, I won't be using this side. This is the one that's damaged. I was paying special attention to preserve the oil vent hose on this side, but in fact, this is the side that's going to be a paperweight, so maybe that wasn't really necessary. P.S. Removing this oil vent hose, you just pull it out. That's all you do. You grab it, and then you pull it. Maybe it was helpful that this was warm, but you just pull it out. That's all you got to do. Now you know. I'll be reusing this side of the case, bolting it to a replacement PTO side of the case, and building this 262 back up. If you watched this far, thanks for sticking with it. I hope you found this interesting or maybe entertaining as I kind of fumble my way through it. I'm not an expert. I don't do this every day, but it's definitely doable by the home user if you just take your time, do a little research, and hey, maybe even this video helped you a little bit. If it did, hit that like button. If you've got questions, throw them in the comments, and I'll be back with a part 2 to show the build back up. Thanks for watching.